ಮೈ ಡಿಯರ್ ಫ್ರೆಂಡ್ಸ್, ನಿಮ್ಗೆಲ್ಲ ತಿಳಿದಿರೋ ಹಾಗೆ AIDSO ವಿದ್ಯಾರ್ಥಿ ಸಂಘಟನೆಯಿಂದ ಇಂದು ಡಿಪ್ಲೊಮೊ CET ಎಕ್ಸಾಮ್ ತಕ್ಕನಂಗೆ ಆನ್ಲೈನ್ ತರಬೇತಿ, ಆನ್ಲೈನ್ ಕ್ಲಾಸಸ್ ಅಂತ ಹೇಳಿ ಮಾಡ್ತಾ ಇದೀವಿ. ಅದರಲ್ಲಿ ಇದು ಮೊದಲೇ ಸೆಷನ್ ಸಿವಿಲ್ ಇಂಜಿನಿಯರಿಂಗ್ ಸಬ್ಜೆಕ್ಟ್ ತಕ್ಕನಂಗೆ ಇವತ್ತು ಆನ್ಲೈನ್ ಕ್ಲಾಸ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಅದಕ್ಕೆ ನಮ್ಮ ಸಂದೀಪ್ ವಟ್ಟರ್ ಸರ್ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು BLDE ಅಂತೇಳಿ ಇಂಜಿನಿಯರಿಂಗ್ ಕಾಲೇಜು ಬಿಜಾಪುರದಲ್ಲಿರೋದು. ಆ ಕಾಲೇಜಲ್ಲಿ ಅಸಿಸ್ಟೆಂಟ್ ಪ್ರೊಫೆಸರ್ ಆಗ್ಬಿಟ್ಟು ವರ್ಕ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಆ ಸರ್ ಇವತ್ತು ಇಂಜಿನಿಯರಿಂಗ್ ಕಾಲೇಜು ಸಿವಿಲ್ ಇಂಜಿನಿಯರಿಂಗ್ ಸಬ್ಜೆಕ್ಟ್ ಬಗ್ಗೆ ನಿಮ್ಗೆ ತಿಳಿಸ್ಕೊಡ್ತಾರೆ. ಸರ್, ನೀವು ತಿಳಿಸ್ಬೇಕಂತ ಹೇಳ್ಬಿಟ್ಟು ನಾವು ನಿಮ್ಮಲ್ಲಿ ಮನವಿ ಮಾಡ್ತಾ ಇದ್ದೀವಿ.
Okay, thank you. Okay, I hope I'm visible. Sir, whether the syllabus copy is visible? Hello?
Sir.
Sir, syllabus copy visible is sir?
Yes sir, yes sir.
Can I start? Chalu madbodre?
Yes. Yes sir. Okay.
Students have joined, alla?
Yes sir, yes, joined.
Okay, thank you. So,
okay sir.
We'll quickly look into the syllabus of civil engineering department. So after looking into the syllabus, we can discuss some of the questions. While discussing this, what we can do is that I'll go through the syllabus content, everything, and while discussing the content itself, I would be discussing all the components and topics also. Okay, so I basically I work as a faculty in BLD's Engineering College, Civil Department. Now that you can see the syllabus copy of CET. So there are so many subjects, most of the subjects that you are already aware about, but I would be discussing on the topics or subjects which I have completed my masters. Okay, so my mastery is in water resource engineering. So I'll be focusing only on hydraulics, fluid mechanics, water resource engineering. Okay, so we'll quickly first discuss the fluid mechanics or hydraulics part. Then we'll go for water resource engineering. After that, we can discuss the other chapters if it is required. Okay, right. So Bhimu sir, ನೀವು ಯಾವಾಗ ಸ್ಟಾಪ್ ಅಂತೀರಿ ಅವಾಗ ನಾನು ಸ್ಟಾಪ್ ಮಾಡ್ತೀನಿ, so that this flow will continue. Okay, I won't be interrupting anyone. So if there are any questions that have been asked in the chat section, you can ask me the question later. Okay, so first we'll start with the hydraulics. As you can clearly see here, I hope this is visible to you. So these are the topics which are to be discussed in hydraulics. First is fundamentals. In fundamentals, we'll discuss about the properties of fluid, total pressure, center of pressure on circular, rectangular, triangular, vertical plates. Then we'll discuss about what are the different types of flow and what are the governing equations like Bernoulli's equation, continuity equation, and other application parts. We'll start discussing about the application part like hydraulic jump. What are the types of orifice we have, hydraulic coefficients of the orifice. Then there are several discharge measuring instruments like notches and weirs. We'll be discussing on them. Then at last we'll be discussing the flow through channels. When the water flows in the channel, what are the hydraulic properties of that? Okay, so we'll be discussing about most economical section, flow through pipes, and when the water flows through the pipe, what are the losses of energy that will take place, and what is hammer, what is water hammer, and surge tanks. We'll look into the water resource engineering later, but first let me just read out what are the topics that we have in the water resource engineering. Okay, first is hydrology. We'll be discussing about hydrological cycle, precipitation, evaporation. These are the different components of hydrological cycle. We'll be discussing all of that. Later we'll be discussing about irrigation. In irrigation, what are the basic terminologies and how those terminologies are going to help us determine the water requirement for irrigation. Later we can discuss about reservoirs and dam. What are the different types of reservoirs we have, and what are the cross drainage works when you are going to construct for canals. What are the types of canal we'll have, canal alignment, canal lining, what is the difference between that. Then there are diversion and river training works like weirs, barrages, canal, headwork, all of those things. We'll be discussing all of this in brief later. Okay. Last part is groundwater. Okay. Now, as your coordinators have told me that there is very small time left to you to study all of this, I hope I would help you in some way to solve some of the questions. So I have taken two question papers with me. One question paper is from 2018, the other one from 2017. So we'll be discussing all the questions belonging to my topic, okay, which is hydraulics and water source engineering, right? So first, let us start with hydraulics. In hydraulics, we have properties of fluid. Just to make a comparison, what I'll do is there are several properties that you discuss in your solid mechanics also. When I say the properties of fluid, when you look into the fluid, what are the properties that you are going to see, and how those properties are going to help you understand the nature of the fluid. Okay. Now let us go with one by one. First is density. We all know what is density is. Density is basically weight per unit volume, right? So, sorry, mass per unit volume. So, what is the unit of that densities? Unit is like it is gram per meter cube. Is correct now? Right. Mass is represented in terms of grams or kg, and volume is represented in terms of meter cube. So that's why the unit of density is kg per meter cube or gram per meter cube. So once we discuss this density is basically representing in one volume of in one unit volume how much mass can be filled in. So that's what the density is representing. Now we can similarly go to what is our specific weight. Specific weight. Now what do we call it as a specific weight as? Specific weight represents it is the ratio of weight by volume. So if I have to say about weight, weight is represented in terms of Newton. Is this correct? Newton or kilonewton. You can say it in any other terms also. So what is this Newton? Newton is representing a force. Okay. Now, if you all remember Newton's second law of motion, Newton's second law of motion says that the force is equal to mass into acceleration due to gravity, right? So force equals to mass into acceleration due to gravity, m into g, right? So m into g is nothing but your Newton. Okay, so force is equals to mass into acceleration, which is representing in terms of Newton. So Newton per meter cube is representing the specific weight. Now, similarly, the specific weight, density, then we have terms like what do you say, viscosity. I hope you remember what is viscosity. Viscosity is the resistance to the flow. So viscosity is having two types of viscosity. One is dynamic viscosity, the other one is kinematic viscosity, right? So then we have compressibility, then we have bulk modulus, and all of these are the properties from which we could be able to identify what kind of property a particular liquid has got. Now, just to give a quick difference between both of them, if you look at the honey and also if you look at the milk, if you take same volume of milk and honey, if you try to weigh them, you will find out the difference of the density or specific weight. How? You will see that your mercury is heavier compared to that of your milk with the same volume, because mercury is a heavy metal, okay, heavy liquid metal, right? So that's why there is a comparative property which is given to you called as specific gravity. Now, what is specific gravity, or it is also called as relative density? So specific gravity is a ratio of density or specific weight of any given liquid to the specific weight or density of the standard liquid, which is called water, right? So if you take the density, if you take the ratio of density of mercury divided by density of water, that will give you the specific gravity of the mercury. Like this, these are the properties that we have for a fluid. Now we all know what is total pressure and center of pressure. Total pressure is the force that is being applied on different bodies when they are submerged inside the water. Imagine if you submerge any circular plate, any rectangular plate, any square plate, triangle, or any shape of plate. When you submerge it, you can submerge it in three different conditions. One condition is that you can submerge it horizontally, which is parallel to that of the water surface. You can submerge it vertically, which will become perpendicular to that of the free surface, and you can submerge it in an inclined way, so that it will become an inclination with respect to the free surface of water. So in your diploma, you might have studied this, how to calculate the force that is being applied on the plate when it is submerged inside the water in three different conditions. One is horizontal, vertical, and inclined. So the equation for that, if you remember, it would be WA into X bar. X bar is representing the CG, the center of pressure, the CG to the free surface, right? So like this, total pressure, center of pressure, we can discuss about that. So after that, we have flows of fluids. Earlier we discussed the different properties of fluid. From the properties of fluid, we can discuss about what are the types of fluid. So in the types of fluid, let us try to understand what is the difference between types of fluid and types of flow. Types of fluid means I have already given you, mercury is one type of fluid, water is another type of fluid. But if we start studying what is the flow condition, then we will discussing about the flow of fluids. Okay, then comes the types of fluid flows. Okay, first let us try to understand types of fluid. Okay, there are two ways to differentiate the fluid. One is by Newtonian condition. Okay, there is a Newtonian law. So based on the Newtonian law, we could say that a fluid is what kind of fluid, whether it is ideal fluid, it is a practical fluid, or it is any other type of fluid. Okay, so anyhow, the fluid is basically discussed based on the viscosity of the fluid. Okay, so in viscosity, if you remember what is viscosity is directly proportional to the rate of change of deformation. Okay, so if I have to tell in a very simple way, you try to observe how the water flows, how the milk flows. Whenever the water flows, water doesn't leave any trace. But when a milk flows, you will see that there are traces of milk that is left over. Why this is happening? This is happening because of the resistance of molecules or the layers of molecules within the given fluid medium. Okay, right. So that's why different fluids have different set of viscosity properties, right? So if their viscosities, whatever the viscosity that gets generated for each fluid, if it is directly proportional to the rate of change of deformation, then we call it as Newtonian fluids. And all the other fluids which do not obey, like for example ink, or you take an example of paint, all these are fluids, but they do not obey the Newtonian condition, where basically what is Newtonian fluid, Newtonian condition says, the viscosity is directly proportional to rate of change of deformation. Okay, right. So now we will discuss about what are the types of flow we have. Okay, I hope you all remember what are the different types of flow. First is steady flow, unsteady flow, uniform flow, non-uniform flow, turbulent flow, and laminar flow. Then we have one-dimensional, two-dimensional, three-dimensional flows. These are the different types of flow that we have. Now let us try to first discuss what is steady and unsteady fluid. Okay, what is steady and unsteady flow? Anything, like there are several properties that we have already discussed. Take for example pressure, temperature, velocity, acceleration. All these are different properties of the fluid. Density, all these are different properties of fluid. If these properties of the fluid remain same with respect to time, we call it as a steady flow. Okay, if all these properties do not remain same with respect to time, we call it as unsteady flow. Similarly, uniform and non-uniform flow. What is uniform flow? In case of uniform and non-uniform condition, you take any section along a fluid flow condition, right? So if you measure the velocity, acceleration, density, and all these properties of the fluid, if they remain same with respect to space, if they remain same with respect to space or distance, then we call it as an uniform flow. If they do not remain same, then we call it as non-uniform flow. Now, what is laminar flow or turbulent flow? The water that is flowing in a laminar state. It means what? There are several layers of water, which is basically an imaginary thing that we are doing. If all these layers of water are flowing in a laminar condition, then we call it as laminar flow. If the water is intermingling, if the molecules are not flowing in a laminar state, we call it as turbulent flow. Now, if I have to give the example of 1D, 2D, 3D, three-dimensional flows, I'll give an example so that from the example you could be able to understand what are these types of flow. Usually, there are, if you want to trace any object, every object moves in a three dimension. As we know in our engineering, we have three dimensions: x, y, and z planes, right? So if a fluid is moving in a unidirection means in only one direction, either in x direction, either in y direction, or in z direction. So such kind of flows which are flowing in only one direction, we call it as one dimensional flows. If the water is flowing in the river, imagine there is a jet of water. Jet of water is always in whichever direction you display the jet is going to go in that direction itself. So that's why we call it as unidimensional or one dimensional. Now if you try to imagine the water that is flowing in the river, the water that is flowing in the river is going to move in two different planes, in x and y direction. So that's why it is called as two dimensional flow. Imagine the water that is flowing in a river when it is in a flood condition, then it will be moving both in x, y, and z direction also, right? Because of the turbulence, it will move in all the three different directions. So that's why the whenever we want to study the fluid flow, we try to understand how the fluid flow takes in all the three different directions, right? Okay, so these are our types of flow. So once we study the properties of fluid, then we are going to study about the types of flow. After that, we will try to understand what are the governing equations to study the flow condition. First, there is an equation called as continuity equation. So you all know what is continuity equation. You must remember all of the. I guess you all remember it. There is an equation that you have famously used called as Q is equals to A into V. What is Q? Q is basically discharge. A is area of the cross section. V is the velocity of the fluid flow. Okay. So whenever you want to measure a discharge, what you do is that if the water is flowing in a pipe, you take the cross section of the pipe, then you multiply with the velocity, you will get to know how much is the discharge that is going in it. Now, the catch here is, if assume the pipe is either converging or diverging, okay, so the area, cross sectional area, will keep on varying as the discharge will remain constant. Discharge is going to remain constant, but A is continuously changing. A is either increasing. If it is converging, the area is getting reduced. If it is diverging, the area is getting increased. As area increases, velocity will keep on reducing, or velocity will keep on increasing, right? So like this, you can say that discharge will remain constant. So that's why the continuity equation says that A1 V1, assume A1 V1 are the area of cross section and velocity at section 1, and A2 V2, A3 V3, etc. are the velocity and cross section area at different sections. If you multiply the product of these two, if you take the product of A1 V1, A2 V2, A2 A3 V3, they'll all remain same. That is what the continuity equation says. I hope you all have derived this equation, or this equation has been given to you. So this is the famous continuity equation that we have. Okay. Now I hope you have not studied the three-dimensional continuity equation, which you will study in the future when you come to the engineering. So the three-dimensional equation will be du by dx plus dv by dy plus dw by dz will be equal to 0. So that's what the equation we have for continuity. Okay. Now we will not be discussing all of that. Okay. So basic continuity equation is Q is equals to A1 V1, A2 V2, etc. Right. Okay. Now going to Bernoulli's equation. What does the continuity equation gives you? Continuity equation gives you the discharge or the quantum of water that is flowing per second. Right. Now going to Bernoulli's equation. Bernoulli's equation helps you understand what is the energy with which the water is flowing. Right. So the Bernoulli's equation has three different components in it. One is P by W, which is called as pressure head, plus of V square by 2G, which is called as kinetic head or velocity head, plus of Z. Z is representing the datum head or elevation head. So the Bernoulli's equation states that it is a sum of pressure head, velocity head, and datum head, which will remain constant. So according to the Bernoulli is a scientist who discovered this equation, who gave this equation called Bernoulli's equation, which says that P by W plus V square by 2G plus Z will be equals to constant, right? So you take you take any section in a flow of water, you calculate how much is the pressure head at that section, calculate the velocity head, and see what is the datum. Add all of them, you will get to know how much is the energy at that section, right? So that's what Bernoulli's equation is. Now, keeping in mind the continuity equation, Bernoulli's equation, we have uh, derived, or we have developed several measuring instruments, right? Velocity measuring instrument, discharge measuring instruments. So these instruments are going to help us determine what are the flow that is taking place in different conditions, right? So first of all, you can see that you can see that there is a orifice. Let us try to briefly understand what is orifice. Orifice is like a tank is there. In that tank, there is a small opening is been done, right? So the water that is coming out from that opening, we want to calculate the discharge, right? So to calculate the discharge, there are some hydraulic coefficients. I hope you all remember what are the hydraulic coefficients of the orifice are. It is called as CV, CC, and CD. Okay. Now, what is CV is? CV is nothing but your coefficient of velocity. What is CC? CC is coefficient of contraction. CD is coefficient of discharge. Okay. So I'll quickly give you all the equations to just to make you a recap about it. I could not be able to discuss in length about it. I need to get the chalkboard and all of those things which I don't have. So that's why. What is CD is equals to? If you know, you just write down separately so that you will get to know what we are discussing till now. So CD is equals to Q actual by Q theoretical. Now similarly, CV is our Q actual velocity divided by theoretical velocity, which is also given by an equation called as root of 4hy, if you remember it. Okay, this equation is derived from an experimental observation, right? Now similarly, CC. What is CC? Area of contraction divided by area of the jet. That's what these equations are, right? But CC can also be said as CD multiplied by CV. Okay, so these are the set of hydraulic coefficients, and their relationship I have already discussed. So this is what we are going to we have discussed. Okay, now next going to several measuring discharge measuring instruments like notches. There are different type of notches based on the shape of the opening. One is rectangular, triangular, trapezoidal, the and circular are there. For your study, we have only rectangular and triangular notches. I'll just quickly tell you the equation. What are the equations that were given to you? Q actual. If you want to calculate how much is the actual discharge that is coming out from a rectangular notch, it will be Q actual is equals to CD into 2/3 of root 2G into L into H raised to 3/2. That is the equation. Here L is the length of the crust, H is the head of the water above the crust. Now going to triangular notch, the equation is like this: Q actual is equals to CD into 8/15 root 2G tan theta by 2 into H raised to 5/2. What is theta here? Theta is the value, the angle at the apex. And what is your H value? H value is representing how much is the head of the water above the crust, right? So these are the two equations. From these two equations, the notches can be discussed. Okay. Now different types of wears are there. Ogee wear, then we have broad-crested wear, sharp-crested wear, narrow-crested wear. All these are different types of wear that we have. Okay. Next, flow through canals. Okay. Again, when the water flows in the canal, there are different types of flows which you already studied, which you already discussed. Steady, unsteady, uniform, non-uniform. Then there is critical, subcritical, and supercritical flow. These are the new additions in the types of flow. Okay. So anyhow, this discussion about subcritical, supercritical, and critical flow is not there for your syllabus, so I won't be discussing much about it. And we'll go with the next topic, which is the Church's and Manning's formula. I hope you all remember what is Church's equation. V is equals to C root of RS. That is the equation for Church's. Now, what is C? C is the Church's constant. V is the velocity, which you all know. Root of R into S. What is R? R is hydraulic mean radius. So what is hydraulic mean radius? Hydraulic mean radius is given by the ratio of wetted area by wetted perimeter. Okay. So we know what is R. Now what is S? S is the longitudinal slope. So if you want to calculate the velocity in any section or in any condition, whether it is in the pipe or it is in the channel, basically this equation is used in the channel only, right? So if you want to determine how much is the velocity in the channel, we should use this equation called C multiplied by root of RS. First, you need to calculate how much is R, where R is equals to A by P. Then the S value will be given to you and C value will be given to you. From that, we can calculate how much is velocity, right? Now, similarly, we can go with the Manning's equation. What is Manning's equation? V is equals to 1 by N, R raised to 2 by 3, S raised to 1 by 2. Okay. So here 1 by N is called as rigorosity coefficient, okay, which is again given by Manning's table, right? Now 1 by N, R raised to 2 by 3, S raised to 1 by 2 is there. R is basically hydraulic mean radius and S is the longitudinal slope, right? Most economical sections, there are different type of sections that we have for channel: rectangular, trapezoidal, then we have triangular and all of those things. But rectangular and trapezoidal are common, which are commonly discussed. What does the hydraulic? What does the most economical section defines? Your width, bottom width, will be 2 times of depth of flow in the most economical rectangular section. Okay. If you go for most economical trapezoidal section, it says that your top width, whatever the top width is there, it will be equivalent to that of the side slope, right? So we'll be discussing the most economic section later. Okay, right? So we'll go with the flow through pipes. There are different types of major and minor losses. So let us quickly discuss about what is major loss and what is minor loss. Okay, so going with the major loss is also called as friction loss. Whenever the water flows in the pipe, there is a friction that is generated between the water that is flowing and the surface of the pipe. Okay, now whenever the water moves on the pipe, because of the friction, there is a loss of energy. And how do we determine the energy? Energy is determined by the Bernoulli's equation. We all remember this, right? P by W plus of V square by 2G plus Z. In ideal condition, the energy will remain same, but in practical condition, their energy will keep on getting reduced, right? So this loss between two sections is called as head loss due to friction. Okay. Now there is a Darcy-Weisbach equation. Darcy-Weisbach gave us an equation called as HF, which is head loss due to friction, will be equals to F L V square divided by 2G into D. What is F here? F is the friction coefficient. L is the length of the pipe in which the water is flowing. V is the velocity of the pipe divided by 2 into G. G is basically acceleration due to gravity. D is the diameter of the pipe. If you know the diameter of the pipe, if you know the length of the pipe, if we can determine how much is the velocity with which the water is flowing inside, and if you know the F value, we can define what is the loss that is taking place due to friction or major loss. Okay. Now going to minor losses. What are the different types of minor losses that we have? We all remember the minor losses. What are those losses? Due to expansion, due to contraction. Whenever the pipe used to get expanded or when it gets contracted, there is a loss of energy because of the eddies and vortices that are formed at the junction. Imagine there is a 20 centimeter pipe, then you are connecting with the 10 centimeter pipe. So whenever the water flows from 20 centimeter to 10 centimeter or 10 centimeter to 20 centimeter, there are various eddies that are formed. Because of the formation of eddies, it is going to create a kind of loss. Okay, that loss is called as a minor loss, right? So in minor losses, there are list of losses are there. As I said you, gradual expansion, gradual contraction, sudden expansion, sudden contraction are the 4 minor losses. Then entrance and exit loss is there. Whenever the water enter, there is a minor loss. When the water exit from the pipe, there is again a minor loss. Then if there is an obstruction, when the water inside the pipe there is any obstruction, then there will be a loss. If the pipe is going to bend, if the pipe has been fixed with an elbow, then also there is going to be a loss. So these are all the different types of losses that we have. Okay, so I hope you would have understood what is major loss. Major loss is basically the friction loss, friction that is happening between the flow of water and the surface of the pipe. And in case of minor losses, there are several minor losses. One is due to expansion and contraction, then there is exit, entrance, bend, elbow, and obstruction, right? Now going with the last 2 topics which are interrelated with each other: water hammer and surge tank. Let us first discuss about water hammer. Water hammer is something which you might have experienced in your real life. How? If for example if the whenever you open the tap at your home, if the water tank is at a very elevated area, if you suddenly close the wall, you might have seen, if you suddenly close the wall, you will see a knocking sound on your pipe. Okay, so that knocking sound is nothing but the hammer that takes place. Okay, so water has got some weight. When you suddenly stop the flow of water because of the deacceleration, it is going to create an impact at any junction, at any other junction. So that impact which gets created because of sudden closure of the wall, that is called as water hammer. Now, how to avoid this water hammer? You will determine a junction at which this hammer is possible. At that junction, you are going to leak the water. You are going to take away the water which is coming in a backward condition. Okay, if whenever you close the wall, when you suddenly close the wall, the water reflects back. Okay, whatever the water that is getting reflected is being sucked into this surge tanks, right? So you try to imagine a huge water that is being supplied to any village or any city. You will see that the hammer that gets created is in a large quantity. If you allow that kind of hammer, the pipe may get bursted because so much of impact it gets created, right? So to avoid such kind of impact or hammering condition, you'll have to place a surge tank. That surge tank will suck away all the water that is going to create the hammering condition, right? So this is what about fluid mechanics. Okay, so if you guys have any doubt, you either write in the chat section so that we can discuss. Okay, we'll quickly look into some of the questions if they are available, right? Okay, now here are some of the questions that are available from the fluid mechanics which I have pointed out. The total force exerted by a liquid on an immersed surface is termed as. Okay, so what you can do is that you can write in the chat section if you know the answer. Okay, so the total force exerted by liquid on an immersed surface, which you have already discussed. What is that? Total pressure and center of pressure. Whenever you immerse any surface or any plate or anything inside the water, the force that is exerted on it will be called as total pressure. Okay, the correct answer will be C. Okay, mathematically the Bernoulli equation can be stated as, mathematically the Bernoulli equation, you can look into all these equations and try to figure out which is the correct equation. Okay, I have already given you the equation. If you all remember, first of all, we'll go with all the terms, whether the terms are there or not. First, what is this equation? P by W plus V square by 2G plus Z. Pressure head is there, velocity head is there, Z is there. So pressure head is represented by P by W, velocity head is represented by V square by 2G, and the datum is represented by Z. So the sum of this should be equal to constant. So it means this is the right answer. But you can look into the other options if you want to. See here he is saying that P1 square by W is pressure head, which is wrong. Pressure head is only P by W only. Now if you go here what is the mistake that we find? This is written as 3 times of G, Z1, which is also wrong. Now here he has made 2 mistakes in this. He is saying that P cube divided by W, which is not possible. Then he is saying that it is not equal to constant. Okay, this is something very contradictory. Okay, if it is practical condition, definitely it's not going to remain constant. If it is ideal condition, it is going to remain constant. But Bernoulli's equation always says that the sum of pressure head, velocity head, and datum head will be equal to constant. Okay, right, very good. Now the theoretical velocity of the jet at vena contracta is given by the relation. Which of this is correct? The correct answer, if you try to look into here, this is the correct answer, B. V is equals to root of 2GH. These are wrong answers. Okay, only if you know the equation you can just solve it. Okay, if you just remember the equations, you could be able to solve it. Now we'll go to this 85th question. The discharge Q over a rectangular notch is given by. I hope you all remember what is the discharge equation, which I already told you. Where theta is the angle of the notch, h is the head over the notch. Here it is written as match. Actually, it should be written as notch. Okay, don't get confused. So CD, if you remember the equation, I had told you CD 8 by 15 root 2G tan theta by 2 h raised to 5 by 2. You find out the correct answer in this. Okay, I hope this B is correct answer. 8 by 15 is there. CD root 2g tan theta by 2 h raised to 5 by 2 is there. You try to figure out what are the mistakes in the other equations, right? So B is the correct answer. Okay. Now, if there are n number of end contractions, then the Francis formula for discharge over a rectangular weir. Okay, this is the question. If you remember the discharge equation for rectangular notch, you will be able to identify this. This is the correct value. Okay, Q is equals to 2 by 3 root 2g. Whenever there is an end contraction, L should be deducted by 0.1 multiplied by n into h. Okay, root of 2g is there, h raised to 3 by 2 is there. So this is your correct answer. Okay, C, 86C. Okay, so what is hydraulic mean depth? See, I already discussed you what is hydraulic mean depth. R, I told you R, it can be also called as M. M is equals to A by P, as you can see here. M is equals to A by P. The loss of head at the entrance of the pipe is given by, again, this is an equation based, 0.5 V square by 2G. Okay, right. We can go to the next question. In case of Francis turbine, after doing the work, the water discharged at the tail race through these are the different components he's saying. It is called as draft tube. Okay, we have not discussed about the turbines, but if you want to remember, turbine has got several components. In that component, penstock is a component which is going to supply water to the turbine. Impeller is a component which is within the turbine. Nozzle is the nozzle which is fitted at the end of the pipe when it is entering. Draft tube is the pipe. You can call it as a pipe also, which is going to help water come out from the turbine. Okay, so here he is asking that in case of Francis turbine, after doing the work, water discharged to the tail race. So the water that is coming out from the turbine leaves from this component called as draft tube. Okay, so these are some of the solution and questions that I have discussed from the fluid mechanics. So if you guys have any doubt, you can ask me the question. Okay, there are no other questions related to fluid mechanics in this. Okay, right. Okay, can I go with the next one? This is the next question paper that we have of 2018. Guys, you can stop me if you find any question related to fluid mechanics. Okay, right. I hope there is one question here. The theoretical discharge through orifice. How do you find out the theoretical discharge through the orifice? So this guy has ticked the correct answer. A is the area of the orifice multiplied by root 2 gh, which is the velocity, theoretical velocity. Theoretical area multiplied by theoretical velocity will give you the theoretical discharge. Right. Again, here there is one more question which has been asked. The correct question I exactly don't know, but probably this answer is correct. Okay, right? The pipe running partially full behaves like open channel. Okay, even if the water is flowing in the pipe. Okay, if the water is not flowing to its full cross section, it cannot be called as pipe flow. Okay, he is saying that a pipe running partially full behaves like a open channel. Okay, right. So you might have studied in open channel there is a circular section. Okay, so circular sections are basically the pipes itself, but the water is not flowing to the full extent, so that's why it will be not considered as pipe flow, it will be considered as channel flow. Okay, open channel flow. Okay, right. Again, hydraulic mean hydraulic radius value of rectangular channel of width b and depth d is given by. Okay, so the hydraulic radius, you know that it is equals to r is equals to a by p. What is a is equals to b into d. Now divided by perimeter should be done. What is perimeter equal to b plus of 2 times of d. So that is the correct value, correct answer. Okay, the Manning's formula for velocity. I have already given you the Manning's formula. V is equals to 1 by n, r raised to 2 by 3, I raised to 1 by 2. See here, don't get confused. Sometimes r is also called as m and I is called as s. Okay, they can be used intermittently. So do not get confused about it. Okay, the hydraulic mean depth for the most economical rectangular section will be equals to r equal to d by 2. Okay, this is the correct value. So these are the some of the questions which are asked in this question paper. Okay. So now we have discussed about fluid mechanics and hydraulics. So if you guys have any doubt, you just ask me the question in the chat box so that Bhimu will convey the questions to me. Okay, if there are any questions. If there are no questions, if you want me to continue, I'll continue with the water resource engineering. Hello, Bhimu sir.
ಸರ್ ಅದು ಇದು ಲೈವ್ ಅಲ್ಲಿ ಮಾಡ್ತಾ ಇರೋದು.
Okay.
ಸೊ ಅದು ಚಾಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಇದು ಕಾಮೆಂಟ್ ಯಾರು ಹಾಕಿಲ್ಲ ಸರ್. ಹಾಕಿದ್ರೆ ಏನಾದ್ರು ತಗೋಬಹುದು ಕ್ವಶನ್ಸ್.
Okay, now can I continue?
Yes sir, continue sir.
Okay sir, thank you. Okay, now coming with the water resource engineering, water resource engineering can be divided into two different subjects. Okay, one is hydrology, the other one is irrigation engineering. So hydrology, by studying hydrology, we could be able to understand the irrigation engineering. Okay, so first let us try to understand what is hydrology. Hydrology, as you know, hydro means water, logy means study of anything. Okay, so hydrology is basically the study of water or circulation of water on the earth. Okay, now hydrological cycle, what is the hydrological cycle? Similar to that of nitrogen cycle, carbon cycle. In environment, the water travels, or water is having its own cycle in the earth, right? So that is what we call it as hydrological cycle. Now we all know what this hydrological cycle from our childhood only. So first what happens, the water that is available in the ocean, rivers, lakes, or in the ice caps, because of the heat energy that is supplied by the sun, is going to evaporate. The water gets evaporated and all the warm air gets lifted up and it gets condensed, and the condensation will create clouds, and the clouds are going to get heavy. When they create a bulk form of that, it gets precipitated back to the earth. This is what the procedure is. This is what hydrological cycle is. Now when the water reaches the earth surface, the water first flows on the earth, then it connects to the rivers, then the rivers connect to the ocean. So this is the cycle that we have. Okay, so this cycle is basically called as hydrological cycle. So let us try to understand what are the different components that we have in a hydrological cycle. First and foremost is precipitation. Precipitation means what? Whatever the clouds that are formed, or the water that is there in the atmosphere, it will come back to the earth. This is called as precipitation, right? So precipitation has got different forms. The form through which the water reaches the earth surface, one is rainfall, snow, hail, drizzle, sheet. All of these are different types of it. Okay, so these are the different forms through which the water reaches the earth surface, right? So if you remember, how do we measure the precipitation? If you all remember, it is called as Simon's rain gauge. There is a rain gauge called as Simon's rain gauge through which we can determine how much is the precipitation, right? Or we can calculate the precipitation. So once we understand the precipitation, we can go for evaporation. What is evaporation? Evaporation is basically the water that is getting evaporated from the surface of water, of any kind of water structures, right? So transpiration. What is transpiration? Transpiration is basically the water that is consumed by the trees or plants, and those which are uh, the plants which are going to leave to the atmosphere, right? So that's what transpiration is. Runoff. Finally, coming to the runoff. What is runoff? Runoff is the water that is flowing on the earth surface. Rivers, streams, nalas, all these are a form of runoffs. Okay. Computation of average rainfall. How do you do the computation of average rainfall? So we take the average of precipitations of the different stations, and the average will be called as average rainfall. Okay. Now these are some of the hydraulic components that we need to study. From these hydraulic components, we are going to study what is irrigation is. Okay. Now let us quickly discuss about some of the basic terminologies that are used in the irrigation engineering. One is called as base period, crop period, duty, delta, and its relationship. Duty, delta, and its relationship. Okay. First, what is base period is? Base period is basically the whenever you if you are a farmer, you know that if you want to grow any given crop, you apply water before you sow the seed, right? Then you will keep applying the water till the full growth of the plant, right? So once you start harvesting, you will stop applying water to it, right? So the total duration from the first application of water before the harvesting, before the sowing, to the last watering before the harvesting, this entire duration will be called as base period. Okay. Now what is crop period is, sometimes the base period and crop period are used as a synonyms, but the crop period is basically the total growth of the crop, the duration that is required for the growth of the crop is called as crop period. Okay. So base period, crop period, sometimes they are quite similar, okay, for our calculation purpose. Now going with the duty, what is duty is? Duty, if I'm going to supply 1 cubic of water, the amount of land that can be irrigated is called as duty. Like for example, if I supply 1 cubic of water for the entire base period, I'm supplying it for entire base period. Now for example, if you are growing sugarcane, and sugarcane the water that is applied for the sugarcane is for the entire year, which is around 360 years, 360 days or something, right? For the entire 360 days, every day I am going to supply 1 meter cube per second of water. Now, by supplying 1 meter cube per second of water for entire 365 days, the amount of land that can be irrigated is called as duty. Okay, so the unit for this is hectares per cubic. Okay, now similarly, what is delta? Delta is basically if the total water that I gave to you, like for example, if it is collected in terms of depth of water, now whatever the water that you applied on the field from the first sowing to the last watering till before harvesting, if you keep on accumulating that, whatever the depth of water that you get will be called as delta value. So delta value is the total depth of water that is applied for its entire base period, right? So this is what base period, duty, and delta. Let us try to understand what is its relationship. If you all remember, duty is equals to 8.54 b divided by delta. This is what the equation we have. If you remember this equation, so that relation is established between duty, delta, and base period. Duty is equals to 8.64 b divided by delta. Okay, right. So after that, hydrographs, I don't know why this is going to you. Anyhow, it's there in the syllabus. We'll discuss that also. What is hydrograph is? Hydrograph is basically a graph which is drawn uh, y-axis. On a y-axis we'll have discharge, on x-axis we'll have time. Okay. Now what is this discharge? Whenever the water that is flowing in any given stream, okay, we will start measuring how much is the discharge in those streams. Okay, so if you try to plot it on the graph, the y-axis being the discharge and the x-axis being the time, whatever the curve that will be formed is called as hydrograph. Okay, right. So this is what hydrograph is. Now going with what are the types of irrigation and what are the methods of irrigation. Now let us try to understand what is basically the difference between method of irrigation and type of irrigation. Type of irrigation is related to civil engineers. How do we supply water to the farmlands? And method of irrigation is basically the methods the farmer is going to take or he is going to adopt in order to apply water to his field. Okay, I hope you differentiate what is type of irrigation and what is method of irrigation. Type of irrigation is basically reservoir irrigation. which is basically the water that is to be collected in a reservoir and it is going to be stored and you will supply the water. This is called as storage kind of irrigation. Then we have river irrigation, canal irrigation, all of those things. So these are different types of irrigation systems that we have. Now going with the method of irrigation, I hope you all know what are the different method of irrigation: sprinkler irrigation, drip irrigation, border irrigation, check irrigation, flooding irrigation. These are the different methods of irrigation. How do we apply the water? If you remember the drip, I hope you all know what is drip irrigation is. What is basically drip irrigation? There are small nozzles that are fitted at the end of every crop, and those drips are going to supply water directly to the root. And you know what is sprinkler irrigation? Sprinkler system is being set up in your field. The water is being sprinkled at the top of the crops, right? So this is what your sprinkler irrigation. Like this, there are different methods of irrigation are there. Okay. Now coming to reservoirs and dams. Okay. So here, dams and reservoirs. We need to understand what is difference between reservoir and a dam. Reservoir is a combination of several components. Okay, dam is basically a barrier or a structure which is constructed across a river to obstruct the flow of water, right? So dam is basically an obstruction. Reservoir is including of all the components. Like for example, when you want to supply water to the farmer, you are not going to simply construct a dam. You are going to construct spillway, you are going to construct canals, you are going to construct the headworks. This entire, if you include all these components, it will be called as reservoir, right? So reservoir is basically the the structure which is going to store the water, right? Now, what are the different types of dams we have? We have gravity dam, then we have earthen dam. Let us quickly discuss about what is gravity dam is. Almaty dam is a gravity dam. Okay, so what basically this gravity dam explains you? Whenever you want to hold the water, whenever you want to hold the water, you are constructing a barrier across a river, right? So there is a horizontal pressure that will be applied by the water, right? So when you construct a barrier, the maximum force that will be applied is from the upstream side by the water, which will be called as water pressure. So you should have a structure that will be constructed so that by the self weight of itself, it is going to sustain all the load that is coming on it, right? Imagine if you have a heavy wall or anything like that. If you apply a horizontal force, that heavy wall will not collapse because of its, if it's gravity force which is going into the downward direction. If you take a small plank, if you apply horizontal force, it will collapse, right? So this is what the thing is. So gravity dam is basically a dam which is constructed such that its self weight is going to resist all the forces that are acting on it, right? So that's what gravity dam is. Now going with the earthen dam. Earthen dams are basically the lower dams. Its height is very small. It is made up of materials that are locally available, basically the earth material that is locally available, right? Now going with the spillways and gates that you already know. In every gravity dam, you might have seen the small openings within the body of the dam. So those openings will spill all the excess water or surplus water from the reservoir to the downstream side, right? So this is what spillway is. Now distribution and cross drainage works. First, let us try to discuss what are the types of canals. So there are different types of canals based on different conditions. You might have all known, based on the network that we lay, there is a main canal, branch canal, and distributory canal. In the distributory itself, there will be major distributory, minor distributory. Then there will be a water course according to the network, right? According to different conditions, like the purpose, the purpose the canal is being used. Whether it is going to supply water to the power generation, it will be called as power canal. If it is going to be supplied for to feed to some other canal, it will be called as feeder canal. If the canal is used for navigation, it will be called as navigation canal. Like this, there are different types of canal, right? Next, going with the canal alignment. There are three types of canal alignment that can be done. The canal can be aligned along the contour lines. The canal can be aligned along the slope, and the last one is the canal can be aligned on the ridge ridge of the mountains, right? So these are the three types of canal alignment. Canal lining, you all know, the lining basically is done by the concrete itself nowadays. So lining means what? Whenever you create an artificial channel, if you apply it with some impervious material on the border, on the perimeter, it will be called as lining. So canal are artificial channels, which you all know, right? Right. Aqueduct and sluices. Okay, sluices are basically the point or the structure, hydraulic structure, which are constructed to extract the water from a river, lake, or from the canal, right? So aqueduct, what is basically the aqueduct? Aqueduct is the bridge which will carry the water. In a very simple way, if I have to explain what is aqueduct, you know that if you want to cross any valley, what you do is that you construct a bridge, right? Similarly, when there is a canal being constructed, and if the water has to cross any valley, we construct a bridge, and over that bridge we make the water flow. That kind of structure is called as your aqueduct. Okay, so these are some of the topics which we have discussed. Okay, we are going to discuss about weirs, barrages, headworks, all of this later. Okay, so I will quickly go into the question paper. Then from the question paper, we'll solve some of the problems. Okay, right. See here, these are some of the questions that we have from 2017 question paper. Where step landing is available, the method of irrigation adopted. See here, first read the question, then you read the options that we have. Free flooding, check flooding, border flooding, and basin flooding is there. When the land is steep, okay, land is steep, the method of irrigation that will be adopted, it will be called as check flooding. You have to keep on checking the flow of water. Basin flooding is used to basin flooding is basically creating a basin. Within that basin we'll place a plant and we'll apply water to that basin, so this cannot be considered. Free flooding is basically applying water freely, which doesn't have any checks to it, right? Border flooding, you will do the border flooding when the terrain is completely plain condition. Check flooding is done when you want to check the water that is flowing at various levels. So that's why we can say check flooding is the correct answer. You can see the answer key which is available. Okay, the canal aligned at the right angles to the counter. See here, contour is there. If you provide it at a right angle, it will be called as side slope canal. Okay, side slope canal, A is the correct answer. Okay, counter canal, branch canal is not at all an canal alignment. Okay, watershed canal is basically the ridge canal only. Okay, so the correct answer is side slope canal. Okay, right. Gravity dams are generally provided with free fall spillway, chute spillway, tunnel spillway, or Ogi spillway. Actually, this is very contradictory answer, but the common answer which is given to you is Ogi spillway only. Okay, the shape, if you remember, it will be of Ogi shape, so you can tick Ogi spillway here. Okay, an arrangement which is made at the junction of water courses and distributors in a canal is called regulator, canal inlet, canal outlet, sluice gate. Now see here, it will be not called as a regulator here. The water is flowing, see here, the water is flowing from distributor to a water course. Okay, so it cannot be called as a regulator because we are not going to regulate the water that is flowing in the water course. It's a very minor condition. So canal regulator can be eliminated. Canal outlet, canal inlet, we can call it as a canal outlet. Okay, we take out the water from the canal, so that's why it will be called as canal outlet. Canal inlet means what? The water that is entering into the canal, the point from where the water enters into the canal will be called as canal inlet. I have already discussed about sluice gate. What is sluice gate? Is basically a gate which will open the water into the canal. That's why it is called as sluice gate. Okay, right. So these are some of the questions that are going to be solved in this question paper. Now I'll just quickly go into other question paper that I have. Okay, so this question is that the precipitation caused by the air masses which strike the mountain barriers and rise up causing the condensation and precipitation is known as orographic precipitation. See here, those who are from Western Ghats area, Madikeri and all, they know that most of the rainfall that they get is because of orographic precipitation. What happens? Whatever the moisture that is carried from the coastal area, it gets struck with the mountain barriers in the Western Ghats, and that when it's stuck with the mountains of the Western Ghats, the water will precipitate nearby the mountains itself. So if you read the question, you will get to understand what it is. The precipitation caused by the air masses which strike the mountain barriers and rise up, causing the condensation and precipitation, is known as orographic precipitation. Okay, right. We'll read this question. Dash is frequently used to irrigate the orchids, where a circular channel is made for each tree and connected to fluid channel. It should be called as field channel, not fluid. It's field channel, which is connected to supply channel. Okay, so I have already explained you. A small basin is made. Within that basin, there is a plant which will be grown. All of you might have seen the fields where they grow plants like the lemon plants and all the commercial crops that they grow. So what they do is that they create a circular basin. Within that circular basin, they'll grow a plant, and they are going to fill the water within that basin only. So if you read this sentence, the sentence is representing the same thing. So the correct answer will be basin method of irrigation. Okay. Nutrients can be applied directly to the plant roots in dash by adding liquid fertilizer to the water. In drip method, we are applying water directly to the root zone. So we can add the liquid fertilizer to the water, and we can apply directly to the root. Okay, so that's why drip irrigation is the correct answer. Okay, dash reduces the available capacity of the reservoir and useful life of the reservoir. Okay, anyhow, sedimentation is the correct answer, but I'll just try to justify why it is correct answer. How do you define the useful life of a reservoir is? See, whenever the water flows in a stream, it carries a lot of impurities and suspended solids. Now, because of construction of the reservoir, you are going to stop the water that is flowing in a river. When you reduce the flow of water, whatever the sediments that are flowing in the water, they get settled at the bottom of the reservoir only. So as the sediment keeps on collecting in the dam, the quantity of water that can be held in the reservoir will kept on reducing. Okay, so that's why the life of the reservoir is basically dependent on the silt that will be accumulated at the bottom of the reservoir. So this process of accumulation of silt and sediment will be called as sedimentation. So that's why sedimentation is the correct answer. Okay, now similarly, we can read the next question. Dash are the canals which are aligned roughly at the right angles of the counter. This is the same question which I discussed from the 2017. This is called as side slope canal. Okay, you can read this question. The next question. The dash is an arrangement provided to regulate the flow of water through the drainage and the canal when they are cross each other approximately at the same bed level. Okay, let us quickly discuss about what are different types of cross drainage works. One we have discussed, which is called as aqueduct. The other will be called as super passage. The third will be called as level crossing. Aqueduct is when the canal is flowing above the river. Okay, so whatever the structure that you construct, that will be called as aqueduct. If the river is at a higher elevation, if the canal is at the lower elevation, the structure that you construct will be called as super passage. Okay, if both are at the same level, the construction that you do, the hydraulic structure that you construct, will be called as level crossing. Okay, right. So this is the last question. We'll discuss this last question and we'll end the session. In case of dash, the canal bed is lowered and the ramp is provided at the exit so that the trouble of the silting is minimized. It is canal siphon. It will be called as canal siphon, right? So these are some of the questions that are discussed from the water resource engineering. Okay, and I have earlier discussed about the fluid mechanics and applied hydraulics. So if you guys have any question, we can discuss. Okay, Bimu sir.
Yes, sir.
Sir, I have tried to discuss everything that is possible. ನಿಮ್ಗೆ ಏನಾರ ಮತ್ತೆ ಕೇಳಬೇಕು ಸರ್?
ಹಾ ಸರ್, ಇದು ಕಮೆಂಟ್ಸ್ ಏನೋ ಬಂದಿಲ್ಲ ಆ ರೀತಿದು ಕ್ವಶನ್ಸ್ದು. ಆ ರೀತಿ ಬಂದ್ರೆ ಏನಾದ್ರು ತಗೋಬಹುದು ಸರ್, ಈಗೇನು ಬಂದಿಲ್ಲ ಸರ್.
ಓಕೆ, ಶೋರ್ ಶೋರ್. ಅದೇ ಭಾಳ
Okay.
ಗಡ್ಬಡ್ ಆಯ್ತು, ಸಿಲೆಬಸ್ ಭಾಳ ದೊಡ್ಡದೈತಿ. ಐ ಟ್ರೈ ಟು ಜಸ್ಟಿಫೈ ಆಸ್ ಮಚ್ ಆಸ್ ಪಾಸಿಬಲ್.
ಓಕೆ ಸರ್, ಓಕೆ
4 o'clock.
ಓಕೆ ಸರ್. ಫ್ರೆಂಡ್ಸ್
I can continue.
ಸರ್, ಒಂದ್ ಡೌಟ್ ಅಂತ ಹಾಕಿದ್ದಾರೆ, ನೀವು ಕಾಮೆಂಟ್ ಹಾಕಿ ಅಪ್ಪ. ಡೌಟ್ ಇದ್ರೆ ಅದು ಕಮೆಂಟ್ ಮಾಡಿ, ಆ ಡೌಟ್ ಮೇಲೆ ಸರ್ ನಿಮ್ಗೆ ಕ್ಲಾರಿಫೈ ಮಾಡ್ತಾರೆ. ಓಕೆ ಸರ್, ಅದು ಏನೋ ಬರ್ಲಿಲ್ಲ. ಫ್ರೆಂಡ್ಸ್, ಇಲ್ಲಿವರೆಗೂ ಸಿವಿಲ್ ಇಂಜಿನಿಯರಿಂಗ್ ಬಗ್ಗೆ ಸಬ್ಜೆಕ್ಟ್ ಬಗ್ಗೆ DCET ಎಕ್ಸಾಮ್ ಪೂರಕವಾಗಿ ಹೇಳ್ಕೊಟ್ಟಂತಹ ಸಂದೀಪ್ ವತ್ತರ್ ಸರ್ ಅವ್ರಿಗೆ ಧನ್ಯವಾದಗಳು. ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಥ್ಯಾಂಕ್ ಯು. ನಾ ಹೋಗ್ಬೋದ್ರಿ, ಬಿಡ್ಬೋದು?
ಹಾ ಸರ್, ಒಂದು ಡೌಟ್ ಸರ್, ಇದು ನಾನು ಸ್ಕ್ರೀನ್ ಅಲ್ಲಿ ಶೇರ್ ಮಾಡಿದ್ದೀನಿ ನೋಡಿ.
ಡೂ ವಿತ್ ವಾಟರ್
ಅದರ
ಸಪ್ಲೈ.
ಬಗ್ಗೆ. ಹಾ ಸರ್.
I can arrange somebody else, okay, because ನಾ ಇದ್ರದ್ದು ಸ್ಪೆಷಲಿಸ್ಟ್ ಅಲ್ಲ. ಸೊ ಐ ಕ್ಯಾನ್ ಆಸ್ಕ್ ಸಂಬಡಿ ಎಲ್ಸ್ ಇಫ್ ಇಟ್ ಇಸ್ ಪಾಸಿಬಲ್. ಓಕೆ,
ಓಕೆ
ನೀವು ಎಕ್ಸಾಮ್ ಯಾವಾಗದ ಅಂತ ಹೇಳ್ತೀರಿ ಸರ್? ಮೇಡಮ್ ಅವ್ರು ಹೇಳಿದ್ರು, ನಂಗೆ ನೆನಪಿಲ್ಲ ಎಕ್ಸಾಕ್ಟ್ಲಿ. ಎಕ್ಸಾಮ್ ಯಾವಾಗದ ಅವರು?
14th ಇದೆ ಅಂತ.
14th. Okay, today is 11th. Sanitary engineering and water supply. What should we refer for CET? How basically I'm an engineering professor. This is the first time I'm discussing about the topics related to diploma students. ನಾ ಯಾವ ರೆಫರೆನ್ಸ್ ಬುಕ್ನು ಕೇಳಿಲ್ಲ. ಪ್ರೊಬಬ್ಲಿ ಇರ್ಬೋದು, ರಗಡ್ ಸಾಲ್ವ್ಡ್ ಕ್ವೆಶನ್ಸು, ಪ್ರೀವಿಯಸ್ಲಿ ಸಾಲ್ವ್ ಕ್ವೆಶನ್ಸ್ ಇದು ಅನ್ನೋ ಯಾವ್ದಾರ ಒಂದು ಪುಸ್ತಕ ಮಾಡಿರ್ಬೋದು, ಅದನ್ನ ನೀವು ರೆಫರ್ ಮಾಡ್ಬೋದು.
ಓಕೆ ಸರ್, ಓಕೆ. ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.
ಫ್ರೆಂಡ್ಸ್, ಈ ತರಬೇತಿಯನ್ನು ಈಗ ಆನ್ಲೈನ್ ಕ್ಲಾಸ್ ಅನ್ನು ಇವಾಗ ಇಲ್ಲಿಗೆ ನಾವು ಮುಗಿಸ್ತಾ ಇದ್ವಿ. ಮುಂದಿನ ಸಿಲೆಬಸ್, ಮುಂದಿನ ಸಬ್ಜೆಕ್ಟ್ ತಕ್ಕನಂಗೆ ನಾವು ಅದು ನಿಮ್ಗೆ ಇನ್ಫಾರ್ಮೇಶನ್ ತಿಳಿಸ್ತೀವಿ ವಾಟ್ಸಪ್ ಮೂಲಕ. ಅವಾಗ ನೀವು ಜಾಯಿನ್ ಆಗ್ಬೋದು ಫ್ರೆಂಡ್ಸ್. ಥ್ಯಾಂಕ್ ಯು.